Hello, this is Dr. Herat, and we are working on Laplace transforms in the methods class. And I thought I will do a problem similar to the one that you got on your homework set from chapter 6, the first homework set. And what we are given here is a function, and the function is given in the form of a graph. And you need to find the Laplace transform of this function, right? So before we go on and do the Laplace transform, I would like to first of all be able to write the function, which is the function ft here, given by the graph as a functional form, in a functional form. So we see the graph. The first thing we see is that after 1 unit of time, the function is 0. So I can write that down. When t is bigger than 1, ft equals 0. Okay, that's 1. And then we need to figure out exactly what is ft when the time is between 0 and 1. What is ft? And we can see from the graph that it has a linear form for the first unit of time. So I can write down in terms of a straight line equation. So it will be the slope times t plus the y-intercept. But we can see that the y-intercept is 0 here because it goes to the origin. And if you look at the graph itself, the slope is going to be 2 over 1, which is 2. So we can write down your f of t for the first unit of time is going to be 2 times t. Now I do have the function. So the remainder of this video will tackle the Laplace transform of this function. Okay, so let's get to it. So we know that from what we did in class, Laplace transform as defined as the integral from 0 to infinity e to the minus st times the function dt. Alright, so now we have to do it for the problem that is given to us. Now we know that our function is in two segments. The first is from 0 to 1 and the second is from 1 to 2. So I need to break down my integral from 0 to 1 e to the minus st. The function is 2t for the first segment plus from 1 to infinity to the minus st times 0 dt, because the function is 0 for the second segment, right? So now let me push this down a bit. Okay, so now we had to do this integral, right? So we only are left with one integral here. So our integral becomes 2 times 0 to 1. Let me write a little bit differently here. T times e to the minus st dt. Okay, now how do you solve this integral? So let me remind you of what you have done in Calc 2 class, which is if you have integral a to b u dv is equal to uv from a to b minus a to b v du. Okay, so that's something that you know very well. So here the task is to find what is u and what is v here, right? So let's do this. So let me take u to be t, then du becomes dt, and let me take dv to be equal to the e to the minus st dt. Then v is the integral on the right hand side here, e to the minus st dt. Therefore v is equal to minus e to the minus st over s. Okay, so that's the integral here. So now let me work this out. So I will have f of s is equal to 2 times, so it will be u will be u is going to be t, v is going to be this, so it will be negative t times e to the minus st divided by s, the limits from 0 to 1 minus integral 0 to 1 and it's going to be v du. V is going to be negative, so it's going to be a positive here, e to the minus st over s dt. So that integral we can do, it's just an exponential, so we know how to integrate exponentials. And let me put the brackets here. All right, so let's look at the limits, the first limits. So this is going to be equal to 2 times, when I put 1, t equals 1, you get minus e to the minus s divided by s. That's when I put the top limit. When I put 0, I will get 0 because there is a t here. When you put t equals 0, the entire expression becomes 0. Okay, plus this integral, oops, let me see, it's not actually plus here. When you integrate what's inside in that integral, second integral, you will get a negative, right? It will be e to the minus st over s squared, and the limits of t are going to be 0 to 1. All right, so now we have to do the limits over there. All right, so let's do that. So we'll have f of s is 2 times negative e to the negative s over s negative. Again, put the top unit, it will be minus s over s squared, minus when you put 0, you will get 1 over s squared. Okay. Okay, so now that's the final answer for your Laplace transform of the function given to you. Hope that it's okay. I'm sure I can simplify it further, but I don't want to. And so that's the solution, and I hope you can do the third problem, I believe, in your homework, which is very much similar to this problem. All right, see you in class. Bye.